Hey guys, it's Miss Johnson, and I'm here to bring you our Unit 5 Notes 1. Unit 5 is all on probability distributions. So when we look at a probability distribution, we are looking at a collection of all values for a random variable with their corresponding probability. So we typically see these things presented in a table. When you look at the table, you're going to see all possible outcomes and their corresponding probabilities. And the biggest thing about those probabilities is that they add up to a sum of 1. So you will be able to add all of the probabilities in the table, and since it's every possible outcome, they should add up to 100%, or in other words, 1.0. This next slide is just a review of inequality symbols. So we are going to work with inequality symbols in this unit quite a bit. So you can see less than, greater than, less than or equal to, and greater than or equal to. The nice thing here is looking at these extra phrases that you'll sometimes see that translate into a certain symbol. So not as much as or fewer than is the same thing as less than. More than is the same thing as greater than. Less than or equal to is at most. And that one's a little bit tricky because at most is actually less than or equal to. Same thing with greater than or equal to. At least kind of trips people up. We see at least a lot. At least is actually greater than or equal to. At least means you start at a bottom value and go up from there. So let's take a look at some of these tables and just practice finding these probabilities. So when I look at this probability distribution right here, here's my distribution. I'll get a little better color. So this table right here is my probability distribution. Here are my possible outcomes. So the possible outcomes are 2, 3, 4, 5, and 6. And here are their corresponding probabilities, okay? So when you look at all of these corresponding probabilities, the probability of x equals 4 is 0.38. So says the table. Probability of x equaling 7. Now, this is the entire distribution, which means all these probabilities should add up to 1. You certainly could add them to find out, but since 7 is not in our table, that means that it's actually not a possible outcome. So this probability is 0. If we look at the probability of x being less than 3, x being less than 3 does not include 3, so I'm only looking at 2, which is 0.32. That's the only value less than 3. Probability of x being less than 6 means that I'm looking at everything from 2 to 5. So now I'm looking at all of those, which is 0.32 plus 0.04 plus 0.38 plus 0.17, and I end up with 0.91 there. The other thing you could do for that, the only one you're not including is the 6. So if I did 1 minus 0.09, I get the 0.91 that is my probability, because 100% minus the one I don't want gives me what's left. Probability of x being greater than 10. 10 is not in your table, so again, that's a probability of 0. So anything greater than 10, that's also going to be 0. Let's take a look at example 2. It says the following is a probability distribution for the number of calls in a day a mechanic gets while working for a rental agency. Use the table to find the following probabilities. Okay, so probability of 9 is 0.12. Probability of x being greater than 7. X being greater than 7 means I'm not including 7, but I want everything bigger than it. So I need all of these. So I go through and add them all up. 0.07 plus 0.12 plus 0.06 plus 0.1 plus 0.14 plus 0.03. When I add all those, I'm going to go ahead and grab my calculator. 0.07 plus 0.12 plus 0.06 plus 0.1 plus 0.14 plus 0.03, and I get 0.52 there. So my probability of getting, 0.52, the probability of getting more than 7 calls in a day is 0.52. How about the probability of less than or equal to 11? So less than or equal to 11 means I'm including the 11 now, and I want the 11 and down, which means I'm looking at all of these, okay? Again, this whole thing, sorry, let's get a better circle there. The whole thing adds up to 1, So you could do this a couple of ways. You could add up all of these ones, or you could take 1.0 and subtract the 0.14 and the 0.03, because those are the only two you don't want. Either method would work. I'm just going to go through and add them all up. So I have 0.11 plus 0.19 plus 0.18 plus 0.07 plus 0.12 plus 0.06 plus 0.10. When I add all those, 1/8, my 1 got a little messy there, 0.18 plus 0.07 plus 0.12 plus 0.06 plus 0.1, and 0.83, 0.83. The other way I could have done that is I could have subtracted those. So 1 minus 0.14 minus 0.03 and see if I get the same thing. 1 minus 0.14 minus 0.03, and I do. I get 0.83 there. So either way would work, whatever way works for you. Just recognizing, my app keeps wanting to update, recognizing that you have a sum that is equal to 1.0 will help you out. All right, let's try this last one. Probability of x being between, that's what these inequalities look like, between 8 and 12. And that's inclusive. I'm including the 8 and the 12. So I want these probabilities right there. 0.07 plus 0.12 plus 0.06 plus 0.10 plus 0.14. 0.07 plus 2 plus 0.06 plus 0.1 plus 0.14, and I get 0.49 there. So when your x is in the middle like that, that means you're between those two values. And then you just have to pay attention, is it inclusive or not? These ones were inclusive, meaning we wanted the 8 and the 12. Sometimes they're not inclusive, and then we'd only go from the 9 to the 11. But it just depends on what the inequality symbols look like. Let's take a look at number 3. So in number 3, it says that we have a new probability distribution of the number of red lights stopped at around 4 p.m. driving north on Cedar through Apple Valley. We've all made that drive before. There's a lot of stoplights that go up Cedar before Cedar turns into a highway. So it says use the table to calculate the following probabilities. So there's a possibility of 7 stoplights. Anywhere between 0 and 7 is what you could be stopped at. The first question is, what's the probability of stopping at 4? Now, 4 is a hole. It's missing, okay? I don't know what it is, but I know all the other ones. I also know that the whole table is equal to 1.0. So if I take all the other ones, 0 plus 0.11 plus 0.15 plus 0.25 plus 0.13 plus 0.05 plus 0.03, what do I have accounted for already? 0.11 plus 0.15 plus 0.25 plus 0.13 plus 0.05 plus 0.03. I have 0.72 there. So this is equal to 0.72, which means the probability that I stop at 4 stoplights is 1 minus that. Whatever's left is what I'm looking for, so 0.28. That's my probability for 4, okay? So again, I added up what I knew, and then I subtracted that from 1 to get the 1 missing. Now let's look at the probability that x is greater than 4. Greater than 4 is non-inclusive, so I'm only looking at the 5 to the 7. So 0.13 plus 0.05 plus 0.03, and that's equal to 0.21. And then x is less than or equal to 3. Notice that at 4 p.m. your probability of stopping at 0 stoplights is 0. Like, you're going to stop at a stoplight. So 4 p.m., obviously a very busy time going through Apple Valley. So x is less than or equal to 3 means that I want the 2, the 1, and the 0. So I'm looking at those 3, 0 plus 0.11 plus 0.15. Oh, sorry, this is inclusive. My bad, fix that. Include the 0.25. I missed the equal to sign at first. So that's inclusive, so I want the 3. This is 40, 51. So 0.51 is my probability there. And then between 2 and 5, inclusive means I want the 2 and the 5. So I want these 4. This is where the bulk of your data is. You can see that that's where your higher probabilities are. So this should be a pretty high number. 0.15 plus 0.25 plus 0.28 plus 0.13. Let's add those up. So 0.15 plus 0.25 plus 0.28 plus 0.13. I get 0.81 there. All right. So again, if you have one that's missing, add up the rest of them and subtract that from 1.0, which is your total, to get that missing value. That's going to be a way that you can fill in your table. Last example, now same situation. We're still driving north on Cedar through Apple Valley, but now we're at 7 p.m. So our probabilities look a lot different, okay? I didn't mean to draw on that. So let's take a look here. Now the first question is, what's the probability that x is equal to 7? So 7 is my mystery this time. Again, I still know that my table adds up to 1.0. So I'm going to go ahead and add the other ones. 0.12 plus 0.33 plus 0.2 plus 0.15 plus 0.11 plus 0.04 plus 0.03. I missed my plus in there. Let's see what that is. 0.2 plus 0.15 plus 0.11 plus 0.04 plus 0.03. I get 0.98 there. So that's everything without the 7. So 1 minus 0.98 is going to be 0.02. That's what's filling in that missing hole. Now let's go through the rest of ours. If x is greater than 3, that means I'm looking at 4, 5, 6, and 7. So those ones. 0.11 plus 0.04 plus 0.03 plus 0.02. That's 4, 5, 6, 7. That's going to be 0.2. I just did that quick in my head. 0.11. That's 4, 5, 6, 7, 8, 9. Yep, so 0.2. Less than or equal to 2 means 2 is inclusive. So I include the 2. I want 0, 1, and 2 there. 0.12 plus 0.33 plus 0.20. That is, I'm trying to do this in my head, 45, 55, 65. So 0.65. And then my between, which is also inclusive. So between 2 and 5 means I'm looking at those. 0.2 plus 0.15 plus 0.11 plus 0.04. That is 15, 36, 37, 38, 39, 40, 50, 60. So 0.60. And again, I did a lot of those in my head, but I think I'm okay. So that takes us to the end of our notes for today. Thanks for tuning in. If you have any questions, feel free to come see me and we can chat. Otherwise, work on your practice assignment for Unit 5, Practice 1, and I will catch you next time.